Hey everybody, Mr. Antonucci here, and in this video we're taking a quick but powerful look at Unit 8 for AP Calculus Applications of Integration. We're going to check out both AP Calculus AB and the topics that are specific to BC. Now this is a big unit and it's a turning point. And don't worry, we're not going to learn the actual formulas today. Instead, think of this as a roadmap so that you know what to expect and how to study smarter. Unit 8 is built around big idea number 1. Change. This is using definite integrals to measure how quantities accumulate. You'll see integrals used to model things like motion and net change, finding areas in volumes, interpreting graphs in word problems, connecting Riemann sums to definite integral. The key idea is this: an integral accumulates tiny bits of something, whether it's area, distance, volume, energy, to get a total. You've seen Riemann sums before. Unit 8 connects those approximations to actual integrals and applies them to physical and geometric settings. Just like in Unit 4, this unit is packed with verbal scenarios, diagrams, and modeling. Expect to have to interpret verbal scenarios, extract key information from a problem, choose an appropriate method to solve the problem, and show your work clearly while also explaining what your answer means in context. A lot of students get stuck on, should I integrate with respect to X or with respect to Y? That's normal, but the good news is the more diagrams you sketch, the easier this becomes. And yes, geometric understanding matters. You're building an intuition for what an integral represents, not just how to compute it. Another important piece is that your geometric thinking matters. You're going to be talking about geometric shapes such as disks, washers, and shells. Also, orientation, graphically speaking, whether or not the region that you're looking at should be viewed with respect to X or with respect to Y. Sketches are essential. It's very important that you understand how to sketch and label your regions correctly. Let's talk about Desmos skills you'll actually use. This unit is going to be Desmos heavy. On the AP exam, you need to be able to do 4 primary things with Desmos: graph functions in any viewing window and adjust as necessary, find zeros or the x-intercepts of functions, including intersection points of functions. Third, to be able to compute numerical derivatives. And fourth, compute numerical integrals. Setting up the derivative or integral correctly is the most important part. If you're not comfortable evaluating definite integrals or derivatives with Desmos, this unit is key to practicing that skill. Now let's talk about a heads up for some common pitfalls. Not understanding the distinction between net change and total accumulation. Students often mix these up. They confuse displacement with total distance traveled. So you want to look for keywords like total, accumulated, or net. And make sure you know when your integral represents signed accumulation versus just total magnitude. Another pitfall is mixing up the setup of your integral as doing it with respect to X or with respect to Y. Another thing to keep in mind is that you should not be memorizing formulas, but understanding how to develop the formulas so that you know which one to use in a particular context. Also, not sketching the regions. A lot of students try to do these problems without sketching it first, which leads to a lot of unnecessary mistakes. Now, I want to touch on real quick the BC only topics. They are arc length, and this involves a square root with a derivative being squared. A lot of times these are very algebra heavy and it can get very messy or impossible to compute the antiderivative by hand. So this is where Desmos is going to be your friend. Additionally, the surface area formula that you're going to be working with, same kind of thing. The important thing is to be able to set it up correctly and then dump it into Desmos to get the calculation. And finally, work. Work is often written as the integral of force. These are going to look intimidating at first, but they're going to fit the same exact pattern. You break something into small pieces, write the formula, and then integrate. This unit has a lot of small formulas and diagrams and sketches, so organization is everything. Here are some high impact habits. After each assignment, write 1 to 2 sentence takeaways. Not a summary, just a takeaway. What surprised you? What fixes did you make? Second, you want to keep your sketches organized and neat. Being able to sketch regions is very, very important. And if you get sloppy in how you sketch them, it's going to make it all the more difficult to be able to determine how to set up the formula correctly. So make sure you keep your sketches organized and neat. Third, reflect after assignments, tests, and quizzes. What kind of problems slowed you down? Did the issue come from the setup, the context, your use of Desmos, or some other skill that you may need to refine? These reflective habits make the harder mixed exam problems way easier. So to be successful in Unit 8, keep in mind 3 things. Integrals measure accumulated change. Staying organized is very important, and practice those Desmos skills. So that's your Unit 8 preview. If you understand the big idea of this unit, that integrals measure accumulated change, then all the formulas and applications will make much more sense. So whether you're an AB or BC, stay organized, sketch everything, and practice matching real-world language to the integrals. If you want more guided examples, I'll be posting a video soon for free response and multiple choice questions. Thanks for watching, and good luck as you dive into Unit 8.